Okay, so this is a video on section 5.1, the properties of logarithms. We're going to talk about the three main rules in this chapter and also the fourth one. So let's do the first three. So three rules, and these we use a lot going into the next section. So the first rule is product rule. This says if we have log base A of A times B, what will occur is addition. And if we have the opposite, let's say they gave us a problem that was addition, then we'd switch it to multiplication. So they can reverse. They can go both ways. 2, we have quotient rule. So this says if I have a log base A of A divided by B, that is equal to log base A of A minus log base A of B. So if we had division, this means we're going to have subtraction. This can also reverse. So let's say we had a problem that had subtraction, we have to do division. Now what about the last one? The last one is the power rule, which states log base A to the B to the R is equal to R log base A of B. So the R, let's say it's in the exponential. I'm going to use a different color here. The exponential, if we have a problem that's in this form, it's going to want us to move it to the front. And that's what we see happening here. So now the R is in the front. So it can switch both ways. So if it's in the front here, it's better to solve. But if we want to do a different problem, they might ask us to move it up. So it can move back and forth depending on what we're trying to solve for. And then the last rule is the change of base formula, which says log base A of D is equal to log B D divided by log V A, or log A of D ln over. So in problems we can actually use logarithms or ln. Either one will work. We tend to use logs more, but ln can be used as well. Okay, so we're going to be using the three first ones more frequently than the fourth one, but the fourth one we have to keep in mind as well. Okay, so let's do a couple problems on this. So let's do ones similar to quotient rule and product rule. So let's do this one first. Log 33 minus log of 11 equals what? Okay. So it's going to be a log of some sort. But we're going to want to simplify. So let's see, what rule do we have here? Well, I have subtraction. So if we have subtraction, what rule do we have? Well, let's look at our rules. So the rule that we're using is the quotient rule. So the QR rule. So the QR rule states if I have subtraction, so we have subtraction here, that means I'm going to do division. So I'm going to label this as A, and I'll label this as B. And in a problem that does not have a number for the base, we always know that that number will be 10. So if they don't give it to you, just think there's a 10 there. So we're going to have log base 10 of 33 over 11. So A over B. So 33 divided by 11 is 3. Easy. Let's do another one. Let's do log of 7 plus log of x plus log of y equals log of what? Okay. So let's look at our signs. So what do we have? Well, I see we have all addition here. And these problems, I'm taking them from your homework, and I'm also making other problems as well. So these two are from your homework on XYZ. You'll have a similar problem. So if I have addition, let's see. Okay, addition. Okay, I see I have addition here. So that means I'm going to use the product rule. So PR rule. PR. So that means that all of them are going to be multiplied by each other. So it's a log of 7 times the log of x times the log of y. But since they all have the same base of 10, I'm just going to combine them. So I'm showing you that they're all getting multiplied, but I'm going to turn them all into one log. So it's 7 times x times y. So that means our answer is going to be a log base 10 of 7xy. So that's how we solve for this one. Okay. So let's see if we have one for the power. Okay. So if I have a problem for the power, let's do, using the power rule, let's do log of 100. No, let's do 1,000 to the 5th. Well, we want to evaluate that, but of course the power is not in the right place to evaluate. So this is my other, let's do power. So power rule states that it's in the exponential position. It's going to want to go to the front, in front of the logarithm. So it'll be 5 log of 1,000. Now, if you don't know what that is off the top of your head, you can just go on your calculator. So let's do that. 5 log of 1,000. That's 15. So that's how you evaluate these. But now we want to show when we combine all three together into a problem. And this is where we see, let's see what example of that. So in example 8, let's do a couple that are similar to that. So let's do this one. Let's do log b of x to the minus 2 over y to the minus 4 c to the 8. Okay, so we do have an example of this in our textbook. And that is on, I think it's, example 8a. So we can use this as an example. Okay, so how do we evaluate this? All right. Well, looking at the problem, I'm going to look to see which rule looks most like this one here. And looking at my rules, I see that the quotient rule is the closest to this setup. So the quotient rule, we know again, is if we have log base A over B, this means that it's going to be in the subtraction form. So log base A minus log base A, B. So I'm going to put it into that form first. Now I'm going to keep these two together for now, and then I'm going to do something with them later. So we're going to leave them as A over B. So this will become log B of A. So A is x to the minus 2. And since we know our sign is going to change to minus, it's going to be minus log B of y to the minus 4 times z to the 8. So if you have two of them together, we know that there's a multiplication sign between the two of them. Okay, so now what do? Well, I put them into the right form for now, but I want to simplify the multiplication over here. So what rule is that? If I have multiplication, going back to our rules, okay, multiplication, I'm using the product rule. So the product rule says that if I have a log base A of A times B, I'm gonna get a log base A of A plus log base A of B. So let's turn it into that form. We're gonna leave the left side the same, but we're gonna turn these two into two separate logs. Okay, now we separated them into the right form. But are we done? No, we're not done, because we have exponents. If we have exponents, which are these guys, this one, and this one, they cannot be left that way. So what they're going to want to do is we're going to use something called the power rule. So the third rule we're using is the power rule. So this guy's going to want to come to the front. So all of our powers are going to come to the front of the logarithm. So now it'll be minus 2 log b of x minus log, 4 minus 4 log b of y plus log, 8 log b of z. But you see how we have a negative 4 and a minus next to each other? That's actually going to change to now addition because we have two negatives. So technically it should be minus, but because there's a negative in front of the 4, it changes to positive. So this is our answer. Okay. Now let's do a few problems that have E in them. So I wanted to just go briefly over this. So if they have an E in it, it's actually really easy to solve. Haha, easy. So let's do two examples of this. So we have ln e to the 1.91. Now let's do another one, ln of e raised to the 1/4. So let's find an example of this in the textbook. Let's find it. Yeah, give an example of that in example 3C. So the example that you have in your book says ln e to the minus 0.5. So let's use that as an example. So we know we can write this also as a log. But for now I'm going to keep an ln and I'll change it the other way. So ln e, well, if we're trying to find what the number is raised to, we have to use an e again. E to the 1/4. Well, if it's the same, we know actually our answer is just going to be 1/4. Now again, this is Euler's number. So you may be asking, how do we know it's 1/4? Well, let's look at our textbook. So on the first page of 5.1, we have the inverse property of logarithms that states that log a to the r equals r. So let's look at our example here. So e is going to be our a. E is going to also be our a. The 1/4 is going to be our r, which means that our answer is r. So I'm just using this guy right here to tell me how to evaluate it. So let's do the second one. So ln e to the 1.91, well, we know ln e. Okay. So again, this is a, this is a, this is r, and this is r. What about if we have a value? So let's use the examples in your textbook again as an example. So if we had log base 4 is 64, well, I want to turn it into this form up here. Well, I have to do that by turning in 64 into a power. So we know that 64, using the base of 4, because I want it to have the same base as a, right? So it'd be log base 4, because that's my a. That means my other a has to also be 4. So 4 raised to the what gives me 64? Well, that means 4 raised to the third is 64. So this is also a, and this is r. So that means our answer is just going to be 3, because that's our r. Let's do one more. So the log of 100. Well, they didn't give us a log here. What did I tell in the beginning, or the base here? What did I tell you in the beginning? If we don't have a base, we always know that the base is going to be 10. So that's my a. That means my other a has to be 10. So 10 raised to what gives me 100? Well, 10 to the second gives me 100. So that's r. And r is going to be our answer. So that's how these can easily be evaluated using that inverse property. Okay, so now I want to go back and use our product rule, quotient rule, and power rule again with a little bit more complex problems. So let's do that example. So let's do 6, and let's do this problem. So at this point, I want you to pause the video and see if you can evaluate this on your own and see if you get the same answer as me. And then once you finish, come back and walk through it. Okay. Welcome back. So let's walk through this problem. So the first thing I see is I have values in front of my logarithms. So I know right away the first rule that I'm going to use is the power rule. So if you have a value in front of log, know that you're going to use the power rule first. So all of these guys are want to go into the exponential position. So this is the power rule. And this was number 3. So now I'm just going to rewrite this as log 3 x plus 2 minus log 3 y minus 1 to the 3. Make sure I get that 4 up there. And this is a z. Okay. So let's let's see, what do we do next? We could do either one. We could do the quotient rule or the power rule, or not the power, but the product rule. Let's do the product rule first. I think that's an easier way to go. And the product rule says that if we addition, we multiply. So we're doing this part for next. So log base 3 of x plus 2 to the 4th minus, okay, so now I'm just going to put this into the multiplication form. Since they both have the same base, I'm just going to combine them. Okay. Now we can do the last step, which is the quotient rule. So that means we're going to have all under the same thing, log base 3. Now, what's my A and what's my B? So this is my A, and this is my B. And we notice we're kind of going back to the previous example we did in number 4. So this is our answer. Okay, so let's do one last problem. Actually, I'm going to do 2. I'm going to do 2 that are similar to the classwork that you guys had. So let's do this one first. So here we want to break it down and then evaluate completely. So we want to use the power rule first. So, or the power rule. So that's number 3. And so that will be written as log 3, 9, raised to the 4th. So we're just moving those numbers that are in the front of the logarithm to the exponential position. So if you have a number in front of the logarithm, it's going to want to move there. And the last one didn't have one in front, so it just stays the same. But now that we have it in this form, I want to simplify. So I want to change them to the same base. So this is actually going to number 4. So this is the property number 4 where they have the same base. So I look at each one. This one has the same base for the A. So if we're using, and this is also referring also to the inverse that we had before, the inverse property, R. So we want to get it in this setup. So if I have the same A's here, that's good. So that means this one's evaluated, but the other 2 are not. So we know that the 9 does go into 3. So if I change that, I want to change it. So we know 9 can be evaluated to 3 raised to, let's see, 3 raised to the third, right? Not raised to the third, it's to the second. So 9 is 3 raised to the second. So we're going to write this as this. 3 log, or log 3, of 3 raised to the second to the fourth. I know that one looks wonky right now, but we'll simplify it. Let's do the last one now. So 3, we want the base of 3, but right now 1 over 27. Well, this is going back to the original chapters, I think in chapter 3, where we turn a fraction into an exponential form. So this guy, 1 over 27, I want to turn 27 into a number raised to a power. So we know 3 raised to the third, so we want the same base as 3, gives me 27. But I don't want it in a fraction form, I want it in an exponential form, so we're going to change that to 3 to the minus 2. Or is it 2? No, it's not 2, it's 3 to the minus 3, because I have the 3 power. So then it will be written as 3 raised to the, log base 3, 3 raised to the minus 3. Okay. 3 to the minus 3, because I have the 3 power. So then it will be written as 3 raised to the, log base 3, 3 raised to the minus 3. Okay. Before I move on, I want to evaluate these two. So if we know one of our rules is if we have 2 exponents, we can multiply them. So it'll be 2 times 4. So log base 3, 2 times 4. So now it'll be this, log base 3, 3 to the 8. So now we've evaluated all of them and broken them apart. So then what do we do? Well, we want to do our other rules. So let's see. Well, since they all have the same 3 raised to the 3 for the A's, their A's are all the same. This means that my logarithm can disappear. So they all go away. And then we're left with 8 minus 5 plus minus 3. So 8 minus 5 is what? 8 minus 5 is 3 plus negative 3. We get 0. So this is our final answer. Now with these problems, there's many ways to solve them. This is one way you can do it. I just find that this way is the easiest way for me to solve it, but you can totally solve it a different way. All right, so let's do the last problem. I know this is a very long video, but I wanted to go over as many as possible. So for this one, I want you to solve this on your own and then see if you get the same answer. And I'm just going to give the answer for this one. And see if you can come to the conclusion on your own. This is just a practice for you guys. Okay, so the solution to this problem is log base 2 So if you got this solution, then you're good.